Good morning, everyone. First, I would like to thank the organization inviting me to be here to give a talk. I hope I'm from China, Nanjing University in Nanjing. I hope in future the ophthalmologists of our two countries can communicate further. So today, I would like to talk the role of ocular surface macrophages in herpes simplex keratitis. So this is my content. So I would like to introduce with following 4 parts. So first, I'd like to introduce the ocular surface macrophages. So, you know, in the cornea, the immune microenvironment, first in the cornea, there are located some immune cells under the physiological status. So the resident immune cells of the cornea include dendritic cells, macrophages, and then mast cells, lateral killer cells, etc. So the macrophages we found that is very important, which are located on the cornea. So our research group found macrophages are the most predominant resident immune cells on the ocular surface. So we did a lot of researches. We found among those cells, the macrophages is the most important ones. But how about the role of ocular surface macrophages in HSK? You know, herpes simplex keratitis is the main corneal disease due to herpes simplex virus 1 infection in cornea. It may occur recurrently and leading to a blindness. Until now, it cannot be cured, so it is a big trouble in our corneal disease. Our group found within 72 hours post-infection, a large number of macrophages infiltrate the mouse cornea, predominantly M1 type macrophages. So macrophages infiltration increased in both the central and peripheral cornea. So we did these studies in mice cornea. Also, we found in HSK, the macrophages of draining lymph nodes is significantly increased. But interestingly, the M2 type macrophages in the draining lymph nodes decreased. So the third part, so I would like to show some research progress of ocular surface macrophages in HSK, which we did by our groups. You know, among the macrophages, there's one special type, which is CD169 positive macrophages. So it is as known as SELEC1. It is mainly expressed especially on the surface of macrophages. So this macrophages type can mediate their phagocytosis of foreign pathogens and antigens, thus exerting a strong antigen-presenting functions. So through our studies, we found CD169 positive macrophages in the significantly increased in the corneas when the mice cornea were infected with HSV. Furthermore, HSV-1 virus level increased when we blocked the CD169 receptor. We found HSV-1 virus were totally increased. So we found the CD169 positive macrophages may play a very important role in defending the HSV-1 infection. So based on this, we study more. We constructed a vaccine. This vaccine we can contact to CD169 positive macrophages. So our research group utilized liposomes made of gangliosides, so to deliver the HSV GD antigen to CD169 positive macrophages. So we deliver it on the ocular surface. So we want to see what is function on the HSV infected mice. We found immunization with the vaccine targeting to the CD169 positive macrophages on the ocular surface enhanced the clearance of HSV-1 and played an important role, an effective role in HSK of mice model. And the second part we did is we found PKHB1 is a peptide mimic that can stably exist in the mouse and human serum. So PKHB1 can induce CD47 activation-related immunogenic cell death. Based on this, our research group explored the use of PKHB1 peptide for treating HSK and its underlying mechanisms. Also, we did in mice. We found upregulated the number of macrophages in the ocular surface and the genuine lymph node of HSK mice and enhanced their functions when we inoculate the PKHB1 peptide on the ocular surface of mice. Also, we found it can inhibit the replication of HSV-1 and reduce the severity of HSK disease. Following, I would like to introduce our third part research. You know, not like receptors, an important family of pattern recognition receptors that play a crucial role in the infection of various pathogens. So we found when we enhanced the NLP12 role of the mice, it can defend the HSV-1 infection. So we found overexpression of the NLP12 gene in the mice corneas promotes the activation of ocular surface macrophages, enhanced the antiviral function of macrophages, and activated HSK. Furthermore, adaptive transfer of macrophages overexpression and NLRP12 back to the ocular surface of HSK enhanced the antiviral immune function mediated by ocular surface macrophages and alleviated HSK. So summary and outlook. So from our studies, we can find macrophages are important immune cells involved in antiviral immunity and the clearance of corneal virus in HSK. So targeting specific subtypes of macrophages, selective drug treatments or immunotherapies to enhance the antiviral immune function of macrophages holds promise for the effective treatment and prevent of HSK. Developing the therapeutic method based on ocular surface macrophages and exploring the underlying mechanisms is crucial for better managing and addressing the global viral health challenges posed by HSK.
That was a fantastic talk, really exciting research. You know, it's a disease that's causing a lot of blindness worldwide, and the whole concept of activating macrophages against infections on the surface, I think is really a great concept I haven't heard before. My one question is, because the herpes virus lives in the nerve root, it seems that the activation of macrophages will be very effective on the surface, but once you already have stromal disease, or you have endothelial disease, or herpetic uveitis, we're just preventing the virus from activating from the nerve. Yeah. How effective would the macrophages be at the other forms of herpes keratitis, and in specific, the virus that's in the nerve root?
Yeah, so, you know, herpes simplex virus, when HSV first infection, it can get latent in the nerves. So we did some research on the role of macrophages on the recurrent HSK. So we found when we enhanced the macrophage role of the ocular surface, the recurrent HSK, the rate of recurrent significantly decreased. Also, when the virus gets latent, if we enhance the macrophage role of the ocular surface, the virus the virus activation also was decreased.
Thank you very much.
Thank you.